Okay, here's an example where we're going to find the linear regression of yearly box office gross for movies in billions of dollars in the following years. So what this data is telling us is our data information starts at 1991, and we in the United States, I assume we're talking the United States now. I'm not sure if it's the United States or if it's the entire world. My guess would be it's the United States. Yearly box office gross for movies was $4.8 billion. So when you go to the ticket, to get your ticket to go to the movies, all the movie theaters in the United States took in $4.8 billion for movies in 1991. And you can see as we got through 1999, the dollar value increased. So again, as time increased from 1991 to 1992, so did the dollar value increase. So we're looking at a positive correlation because our X and our Y are working together. So our X value and our Y value is working together. Now, list 1 is your X value, and list 2 is your Y value. So this is the work that you can show on your homework to show what you put into your calculator rather than just putting down answers. So I would put down list 1, X. Now in this case, I'm going to show you something else that the problem might tell you. Let 1991 equal 1, 1992 equal 2, and so on. So you don't always have to say that your first data point starts with an X being 0. They could say 1991 equals 91 and 1992 equals 92. Many times it's defined for you in the problem. If not, that's why you're going to show your work. 1991 will be 1, 1992 will be 2, 1993 will be 3. And then we've got all the way to 1999, so 4, 5, 6, I can count, 7, 8, 9. And then our Y values will be 4.8, 4.9, 5.2, so now I'm going to have a hard time seeing, 5.4, 5.5, I believe that was 6.0, 6.4, 7.0, and then 7.4. So we write our data down, and now we go right to our calculator, and we enter the information. So we'll open up our calculator, and what's cool about the calculator is I'm going to get to show you how we clear the screen. So at this point right here, where you might be on your calculator, we're going to hit exit, and that's going to take us back to list 1 and list 2. However, there's all this data that's in list 1 and list 2. So if you hit exit one more time and then go to this arrow, which is F6, you get the choice to delete all. When you press delete all, it asks you, do you want to delete the entire list? And you hit F1. Because I was in column 2, it deleted list 2. If I scroll over and my highlighted area is in list 1, and I hit delete all, it will delete all the data that's in list 1. Now I can enter my new data, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in list 2, I'm going to enter the billions of dollars. So 4.8 billion, 4.9 billion, 5.2, 5.4. Need to move my screen over. Then we have 5.5, 6.0, 6.4, 7.0, and 7.4. And we do a double check to make sure everything was entered in properly. And now remember, after we entered this, we hit the button that said graph, but graph isn't here right now. So if I hit exit again, it's not taking me anywhere. If I hit F6 twice, it comes back to that first screen of options: graph, calculate, test, etc. So let's hit graph. And then remember, here we hit graph 1, and that actually shows our data. So this looks like a line would fit through this data. So it looks to me like it's a very good linear regression, but we won't know for sure until we see what R is equal to. I hit calculate. I want the X to the first power. That's linear. So F2 would be X. And then I want AX plus B. And there is our data for our line. So let me write this equation down. It is 0.328. So I'm just going to take the first, since it's not the first decimal place that's repeating, I'm just going to take the first 3 decimals. So I'll have Y equals, that's a Y. Let's fix that. Y equals 0.328x. And then I have plus 4.20. Now this 2 is going to become a 3 because of our rules of rounding. So 4.203. 4.203. Now on the previous example, I actually showed you, just a sketch of what this looks like, and then I put a line going through the data. I want to show you on your calculator, you can hit the draw button. On the calculator, we hit the draw button, and it shows you the actual specific line, because we will all get the same specific line. So as long as you entered your data in correctly, as long as you entered it into the calculator correctly, you will get the same line that I got. So you can see that it's going through this third data point almost perfectly. So that's our equation of our line. And we've got one more. And I think what I'll do on this one is I'll give it to you as an example for you to try. Precipitation and temperature in selected eastern cities. Let's see if you can't come up with the equation of this linear regression line. Your independent variable is the temperature. We have no control over the temperature in this case. As the temperature increases, it looks like for a short period of time, the average annual precipitation looks like it's decreasing, but then here it's increasing, and then here we've got a decrease, and an increase, and then another increase. So this one's going to be really important for us to see what's happening on the screen. So it'll be interesting to see when we put this into our calculator where those data points are. Now we're going to have to start with our values. 76.4. You just can't get around it. You can't make this a 0 because these numbers are just varying. It's not time where it's in years. The temperature is going to vary. So we're just going to enter our values as we see them. So in your calculator, enter the values and see if you can't come up with the equation of the line. When you're ready, press play. So make sure you press pause. When you're ready, press play and you'll start seeing the answer. Okay, this is what our data is going to look like. So make sure that you've entered everything in properly, that all the values are corresponding. Remember, I'm going to hit F6 a couple of times until I can get to this graphing button, and then I'm going to press F1, and then F1 again, and we'll see the data, and it looks like it could be linear except for some points right here. So we're going to look at the equation, but we're also going to look very closely at that R value. We hit calculate, and we hit F2, AX plus B, and you can see that the R value is 0.7. It's not a very good correlation. Now, if they ask us what is the correlation, coefficient, it would be 0.7, I think it was 0.72, 0.725. And our equation is y equals 1.576, 1.576x, and then I think it was minus 76.740, minus 76.740. So there's our equation. However, it's got a very low correlation. So it's not very good. If we look graphically at what's happening here, we can draw it, and you can see that there's going to be a couple of data points that are just out of the way. And my computer is going to fall asleep here in a second because I'm running out of battery power, but we made it just in the nick of time. There's our video. Good luck with your homework.